Hello everyone, welcome back to the Rust programming tutorials. Today we're going to talk about collections in Rust, specifically the vector. How do we use it? Different methods associated with it. So different things, we're going to talk about collections. As you all must be aware, collections is nothing but a data structure which allows you to store multiple elements. You can store more than one value in a single data structure. And that the storage is that the values are put right next to each other in the memory. In Rust, one such collection data structure is called vector. The thing about vectors is all the elements, it expects it to be of the same type. If we are storing integers, they all have to be integers. If you're trying to store a string, they all must be string. So that's the limitation of vectors. All the elements must be of the same type. How do you create a new vector? Well, there are two ways. First one, where you define, you use generics to define the type. This means integer 32, and you call the vector.new on it. So this creates an empty vector in the memory. So these are generics. But the good thing about Rust is that Rust provides this vec thing. Okay. So what happens is you don't need to give the generalization. Okay. You can directly create a new vector by giving it initial values, and Rust will in turn determine its type. Okay, it will infer what type are you trying to create, what should be the vector type. So more than often you might not need to declare this using vect generics. Okay, so it can infer this type. So yeah, so vec macro is there, we can take a use of it. So, and of course, when you declare an empty vector, it needs to be mutable in order for you to do any operations on it, like add a new value, delete a value, okay? Some methods, which we will also be seeing in practical, push. What does push do? Push actually adds an element to the end of the vector, okay? See here, how do you read values? There are two ways. One is you give the index. Now, like in most programming languages, the index starts from 0. So 0, 1, 2, 3, 4, that's the index. So like see, the third index is 2 because the element 2 means 0, 1, 2. So this third should have 3. There is another method which is safe. Now I'll tell you why it is safe, is to call the get. Vector.get, and you give the index. Now notice what it returns. It returns an option. As we learned in the previous lecture, option is a special enum provided by Rust. So it has two values, either some or none. So why it is safe is, so let's say you see this has 5 elements. And if you gave here 6, here, ampersand vector.get 6, it should throw an error because there is no 6th element. It has only 5 elements. So your program will fail. Whereas the same index, if you give it here, vector.get 6, the option will return none. Your program will not break, will not get any error. That is why get is a better way of retrieving values from vector. Okay? So if it exists, it will return some with the value. If the index does not exist, it returns a none, and you can handle it. You have the option of handling non-existing element, okay, from the vector. So again, just a brief recap. You can define in two ways, using vector.new or calling this vec macro. If you're Declaring it using vector.new, you got to define the type. What type? Because vectors allows only same type to be stored in the data structure. Here, if you're creating a new vector, calling a macro, Rust will infer the type based on the values what you have provided when declaring. One method that we saw, push, adds element, remember, to the end of the vector. Okay. Two ways of accessing: directly giving pointer and the element, which is little unsafe if you give an index which is not existing. .get, if you give index which is not existing, it will either return some if it exists or none if it does not exist, so that you can gracefully handle errors. Next, let's go over how to iterate. Okay. So here we have declared vectors. So see here, for nref. So we have the for loop here available in &v. Okay. So what you're doing is creating +1, just simple nref +1. So pointer, whatever the nref is pointing to, nref is nothing but a pointer, so it should print 101, 33, and 58. Or you can have a mutable vector and update the vector itself. So this, what you're doing is just creating another variable n+1 by using the value whatever this nref is pointing to, and then you're just printing it. Here what you're doing is, because notice, see here the vector is not mutable, so you cannot update the values inside it, but here the vector is mutable. So here what you're doing is directly whatever this is pointing to plus 50. So you're adding 50 to every element of the vector. How does under the hood this works? Iterator inside, internally, it's a pointer. So see here, when you declare a vector, v, and you get an iterator for it. So iterator C points to the first element. What you do, when you call iterator.next, unwrap, it goes to the, initially when you declare it, it's pointing to the first element. But when you do unwrap, it points to the next. See here, L2 goes to the next. Okay, and N1, here this N1 still points to the first one. Now here, L3, N2, what it is doing is wrap.next. There is no next. So this is gone. Okay, this is gone. And then what you have is, since you did N2, N2 points to the second element, N1 points to the first element. So here, actually, the iterator is pointing to the beginning, not even to the first element. It's pointing to the beginning. So when you call next, it moves to the first element, okay? And then it goes to the second. And once here, when you call iterator.next, there are no elements, it will return none, okay? Because the vector iterator is not even there. You have already traversed through the entire collections. So this is how internally in the memory iterators work. So it's nothing, a pointer which moves to the next element every time you call next. Unwrap is because it returns it returns an option. So unwrap, what it will do is give you the element of the sum, okay, the value which is there. So remember, sum has got unwrap method, which allows you to extract the value. So let's see some example. In practice, so let's see here. All right. So here I have a code here. If you see, we are declaring a vector. Now see here, v2 is a new vector and every element of this, what you're doing is you're taking mutable v and you're pushing it into v2, the second vector. What happens here is you're putting a reference of v into v2, not just copying the values. So when you change the value of the first element, automatically the first vector's element also change. So what you're doing is v2, whatever it's pointing to, you're assigning the value 5. So when we print A and B, both should be 0. Here, this is an example of push, pop, insert, and remove. So another mutable vector, numbers. What you do is, now see, notice here, it's defined using the macro. So we are not giving any type or anything, right? Now what you're doing is push 4. Now push, what it does, it adds to the end. So now the vector should be 1, 2, 3, and 4. So when we print, we should expect the output 1, 2, 3, 4. Pop. Pop, what it does is removes the last element. So now 4 would be removed. And when you pop, it returns an option, which is sum 4. Okay. And after pop, you should expect these to be same. There is also one more method, which is insert, which allows you to insert at a specific position. See, push and pop always works from the end. But insert and remove gives you the flexibility to insert an element at a specific position or at specific index, or remove it from a specific index. So see, for example, here, what we are doing is inserting at the first position, not the 0, but the first position. So the output should look like this. Because this is the 0, then the first position is 2. So here the 5 will come and everything else gets pushed to the right. Remove, again removes and pulls everything towards the left. Let's run this program and see. Again, 2 means 3, right? Third element, 0, 1, 2. So the 2 is removed. And then you're left with 1, 5, and 3. So notice that 3 gets pushed to the left. Let's see this in action. We do cargo run. See here, both must be same, 5, 5. So here you can see after push, 1, 2, 3, 4, that is what we were expecting. Removed element, sum. So notice it's not actually the value 4, it returns sum because it's an option it's returning. After pop, the last element gets removed. Insert, as we expected, we inserted at first position. So first is 0 and 1 here, 0 and 1. So 2 and 3 gets pushed to the right and 5 gets inserted at position 1. When you remove something at index 2, which means we are removing at index 3, 0, 1, 2. So see, as we expected, 2 is removed. And this is the vector which is after this. So that is all for today. We just did a quick understanding of vectors. Please feel free to try it out. Okay. And thank you for your time. See you all again in the next with string collection. All right. See you all in the next lecture. Thank you.